Hello students, welcome back to my channel. How are you all? So in today's video, I'm going to talk about chemistry of alkanes. As I promised you all that in the next video, I'm going to explain you hybridization of alkane, bond angle in alkanes. So let's go. Okay, so alkanes, as I told you, they are saturated hydrocarbons. Okay. Alkanes, also known as paraffins. Why alkanes are called as paraffins? Due to its stability. Okay. Stability. Then, as I told you, carbon is tetravalent. Okay. Then we talked about classification of saturated hydrocarbons, and we said it is of two types, open chain and closed chain. Alright students, I hope till here you remember we have already discussed everything, all the points in detail. Okay, so open chain, also called as acyclic alkanes, and closed chain, also called as cycloalkanes or cyclic alkanes. Okay, if you remember, I have already given you the general formula of alkanes, which is CnH2n plus 2. So when you are writing this formula, it means your chain is open chain. Okay, when you are writing saturated hydrocarbon in closed chain, the formula will be CnH2n. So you can see that in closed chain, the number of hydrogen atom is less compared to open chain, being both are saturated hydrocarbon. Examples already we have discussed. If you want to see the example of open chain and closed chain, please check my previous video. You will get open chain and closed chain examples. Alright. Now, next topic is structure. Okay. Structure of alkane. Okay, we know that in alkane, first member is methane. What is the molecular formula? Is CH4. Carbon is tetravalent. All valency is satisfied by 4 other hydrogen atoms. Okay. Now, hybridization in methane is sp3. If sp3 hybridization, what will be the geometry or structure of the molecule? It is structure or geometry of molecule is tetrahedral. Okay. Bond angle is 109.5 degrees. Okay. So this is hybridization where s and p orbitals are taking part in hybridization and forming 4 degenerate orbitals. Okay, so if I want to show you the structure of alkane or structure of methane, how we can draw. Okay, so sp3 hybrid orbitals, how we can draw. Okay, so as we are saying, methane is tetrahedral, means we have 4 sp3 hybridized orbital. Okay, each orbital is sp3. As I told you, it's a degenerate. The energy of each orbital, degenerate means energy of each orbital is same. Now these 4 orbitals overlap with 4 different hydrogen. Okay, the nature of hydrogen same, but 4 hydrogen atom to complete the structure, to complete the octet. Okay, we know that what is octet? Octet is nothing but that 8 electrons in the valence shell. Is this clear? Okay, so this is hybridized structure of methane. Okay, if I want to represent this overlapping, hydrogen overlaps with sp3 hybridized orbital of methane. This hydrogen is also overlapping with this orbital. This hydrogen is overlapping with this, and this with this. So we have 4 hybridized orbital. Okay, the same structure we can represent as tetrahedral. The shape, the geometry of the molecule is like this. All right. Okay, so this is the structure of methane. This is the hybridized structure of alkane or methane. Okay, so our next topic is nomenclature. As I promised you that we will do some IUPAC nomenclature or IUPAC naming of alkanes. So our next topic is nomenclature. It's a very interesting topic. Okay, if you know all rules properly, definitely it will be very easy scoring also. So let's start. Let's take some example of nomenclature. First we'll start with a simple compound and later we'll increase the complexity. Now first CH3, CH2, CH3, CH2 and CH3. Okay. Okay, please pause the video and try to write the name of this compound. Okay, so already I have informed you, whenever you take my class, please maintain one notebook in which you can write down all the notes. Okay, I hope you have written the name of this compound. Let's see what will be the name. So we can see, as it has no side chain, it's a straight chain, so I can use N. N stands for normal. Number of carbon atoms 4. But, all single bond, and butane. It's very simple. Already we have done. Okay. Now next compound is this. How many of you can write? Please try to write the IUPAC name for this compound. This is number 1. This is number 2. Okay. Now, how you will write the name of this compound? You have to select the longest continuous carbon chain. So I can select this chain. Okay. Where I am getting 1-methyl as a substituent. So according to IUPAC nomenclature, you have to name substituent first with its position followed by the root word and the suffix. Okay. Now when I am going to start numbering from left to right, 1, 2. Second position carbon atom has methyl. Okay. Or if I start from right to left, 1, 2. Second position only methyl group is getting. So we can start numbering from any way. So start writing. 2 is the position of methyl. So 2-methyl, 3 carbon atom, prop, all single bond, propane. Is this clear? Children, anyone, any doubt? Okay. Now, please practice for 2 to 3 more, so that will be more clear to you all. Okay. So, CH3, CH2, CH2, CH, CH3, CH2, CH3. Please pause the video and try to do it. Okay, I hope you guys have written the name. Let's see, are you also getting the same name? Okay, so we have to take longest continuous carbon chain. Let's see. As you can see, it has one side chain. Okay, so if I take the straight chain, 1, 2, 3, 4, 5. Okay, this is one of the possibility. Or 1, 2, 3, 4, 5, 6. So definitely if I'm going to take the straight chain, I'm getting only 5 carbon atoms. But if I take this L-shaped chain, I'm getting 6 carbon atoms. So I will go for the more number of carbon atom chain. Okay. Now we can see we have methyl as a substituent. We can see methyl as a substituent, right? Start numbering. So what is the rule? First, select the longest continuous carbon chain that we have already selected. Second rule, give the possible least number to the substituent. So we have methyl here. Let's see. If I start numbering, down to up, 1, 2, 3, 4, 5 and 6. Okay? Or 1, 2, 3, 4, 5 and 6. So if I start numbering from left to right, okay, so I can say that when I did numbering from left to right, okay, my methyl is coming at 4th position. When I do numbering from right to left, my methyl is getting position 3. So definitely I will go with the position number 3, as we have to give the possible least number. How to write position of methyl group? 3 methyl, okay, number of carbon atoms 6, hex A. I hope it is clear to everybody, right? One more example I'll take, then we'll start cycloalkane. All right, now C, C2H5, C, CH3, CH2, CH3. Okay, you have to substitute, you have to satisfy carbon valency. Done. Okay, please pause the video and please try to make it. Okay, is it done? Let's start. Again, continuous longest carbon chain. Let's see the possibilities. 1, 2, 3, 4, 5, 6. Okay. Then 1, 2, 3, 4, 5, 6, 7. Definitely I will go with the 7 carbon chain. C2H5 is nothing but CH2, CH3, which is our ethyl group. So this group C2H5 I can also write as CH2, CH3. I'll just write it more clear. CH2, CH3. Okay. Now my chain will be this. Okay, L-shaped chain. We can see we have 2 groups which we have not included, that is methyl group. Okay, so let's see, give the numbering. 1, 2, 3, 4, 5, 6, 7. So when I did numbering from right to left, I got 3 and 5. Okay, that is from my left to right. Sorry, right to left. Okay, right to left. Alright, when I do numbering from left to right, okay, 1, 2, 3, 4, 5. So here also 3 and 5. Okay, so here if your substituent is getting different position, okay, so you have to check with the lowest sum rule. You have to add the position wherever you are getting lowest sum. You have to go for that numbering. Okay, but in my case I'm getting same position, so you can start numbering from anyway, any side. Okay, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so I'm going to write first position as we both have methyl group. Okay, so 3, 5. How many methyl do we have? 2. So we are going to put prefix di. Di is for 2. What do we have? 2 methyl. So 3, 5 dimethyl. Number of carbon atoms 7. So root word will be hept, all single bond ene. 3, 5 dimethyl heptane. Okay. If I do the change here only, in this chain, if I put CH2, CH3, instead of methyl, if I put 1 ethyl and 1 methyl, right? So I will give possible least number to ethyl, then methyl. Okay. Now 3 ethyl, 5 methyl. Okay, because it starts from E, alphabetical order. And I will write also 3 ethyl first. So for this compound, I can say this should happen, otherwise my video cannot be complete. Okay. Okay, so 3 ethyl, then hyphen 5 methyl, heptane. Every time this thing happen, marker lid, this fell down today also. All right. Is this clear, children? Please copy it quickly. Then we can start cycloalkane. Okay, I hope it's clear to everyone. Now, next is cycloalkane, the nomenclature of cycloalkane or closed chain structure. So, heading you have to put the heading cycloalkane. Okay, cyclo, as I told you, cyclo means closed chain. Okay, general formula CnH2n, that also will cross check. Okay, first member of cycloalkane is, this is cyclo, 1, 2, 3, 3 dots means 3 carbon, cyclopropane. Okay, so when I am going to write, I'll write CH2, CH2, CH2. Okay, any doubt? Is this clear? Okay, now here our N value is 3. We have 3 carbons, N value is 3. When I substitute 3 value in this formula, C3H2 multiplied by 3, C3H6. Are we getting C3H6? 1, 2, 3, C3, 2, 4, 6, C7. So this general formula is okay for cycloalkanes. Okay, now what is it? Children, I have already told you what is it. When you do not have alternate double and double bonds, we consider it as a cycloalkane. Which cycloalkane? Checkpoints 1, 2, 3, 4, 5, 6. Close chain prefix cyclo, 6 is hexane. Okay, cyclohexane. If I put one group here, you will consider this as a substituent. Substituent always before the compound name. Which substituent is it? Methyl cyclohexane. Methyl cyclohexane. You can also write 1 methyl cyclohexane, but you can see only one substituent is present, so no need to give the position to the methyl group. Okay, now if I write again cyclohexane, okay, one if I put methyl here, one I put ethyl here. Okay, how I will give the name? Start numbering. Now 1, 2, 3. At first and third position I have substituent. Okay, if I start numbering from 1, 2, 3, again the same thing. So if ethyl and methyl, if the position of these two are same, and if you are getting the same number, so I will prefer to give least number to ethyl and then methyl. Okay, so you can write 1 ethyl hyphen 3 hyphen methyl, root word 6, before that cyclohexane. Alright children, so this is about the nomenclature of cycloalkane. Our next topic will be the preparation of alkanes. Are you guys ready to do that? Copy it down. We'll start in few minutes. Okay. Please put the next heading, preparation. Now we are going to discuss how we can prepare alkanes. Okay. So our topic is preparation. Preparation of alkanes. Okay. So here we are going to talk about the recipes. Right. If you like anything to eat, you always look for the recipe, right? The same way we are going to make alkanes by using different material. Okay. So under this topic, we are going to discuss different ways or different compounds we can use to prepare alkane. Okay, are you guys ready? Let's start. My first preparation method from which I can make alkane is nothing but unsaturated compound. Okay, so first is from unsaturated hydrocarbons. Okay, children, if you remember what unsaturated means, already we have done this topic. Unsaturated, un means not, saturated means satisfied, whose valency is not satisfied by single bond. Or unsaturated means presence of double and triple bond. Double or triple bond, double on and triple bond, anything can be possible. So first example, first member of alkene family I am going to use to make saturated hydrocarbon. Quickly tell me the name of this compound. Please write in the comment section. What is it? 2 carbon atom. We use eth, and presence of double bond gives you the suffix -ene. So this is ethene. So ethene, when it undergoes hydrogenation, okay, this is also called as hydrogenation. Hydrogenation means addition of hydrogen. Addition of hydrogen. Okay. So, as I can see, this is double bond. And out of these two, one is sigma and one is pi bond. Okay. So, hydrogen you can also write in HH form. So, one hydrogen will attack on this carbon atom. One hydrogen will attack on this carbon atom. Reason? This pi electron is unstable. And this electron, we know the electron is negatively charged. It will attract positively charged ion. Okay. So, hydrogenation always takes place in the presence of a catalyst. Which catalyst? So, for hydrogenation, transition metals can act as a catalyst. So, it can take place either in the presence of nickel or platinum or palladium. Any one catalyst can be used to do the hydrogenation process. Okay. So, if you are taking these catalyst always provide its surface for the chemical reaction. Children, what do you mean by the catalyst? Catalyst do not participate. Catalyst, any of the catalyst, wherever you find the term catalyst does not participate in the chemical reaction. What it does? It only provides what? Its surface for the chemical reaction. Is this clear? So, catalyst provides the surface for the chemical reaction, does not participate in the chemical reaction. So, here this nickel, platinum, palladium will provide its surface. So, you can see these two hydrogen will attach in this way and can attack, and this whole thing will come and attach on the pi bond. Is this clear? So, when it will attack, this pi bond will break and will left with CH2 and we know that it is unstable. What is the reason? Carbon valency is not satisfied. So, this hydrogen will attach here, one here. What did we get here? CH2 plus 1 hydrogen becomes CH3. CH2 plus 1 hydrogen becomes CH3, and we got our saturated hydrocarbon from unsaturated hydrocarbon is ethane. Is this clear, children? Okay. Please star mark. Very important point in this process. So due to presence of catalyst, okay, as we are saying, hydrogenation process is possible only in the presence of catalyst. So because of presence of catalyst, this complete chemical reaction is also known as catalytic hydrogenation. Due to presence of catalyst, catalytic hydrogenation, this process is also known as catalytic hydrogenation process. Is this clear? All right. Now, as I'm saying, these transition matters can act as a this catalyst, which is a characteristic feature of a transition matter. They work, they react, they provide its surface at high temperature. Okay, that's why we say always like copper, zinc, nickel, they are very, very strong metals and their melting point is very high. So they will provide their surface only at higher temperature. Okay, is this clear? So this high temperature I am talking about only for nickel. Now as I can say, this reaction can take place in the presence of nickel or platinum or palladium. So all are transition metal, but the behavior, the nature of these catalysts are different. Like nickel can work only at high temperature, while platinum, palladium can show their reaction, can do chemical reaction at room temperature also. So next star point is nickel needs high temperature for the chemical reaction, and platinum or palladium, they can react at room temperature. Is this clear? Okay. So this is our first preparation method from unsaturated to saturated hydrocarbon. Okay. Please note it down quickly. Okay, let's start our next preparation method. Please highlight the important point, the star points. Please highlight. It will be easy for you during the exam time. Okay. So, my next preparation method, my next recipe from which I can prepare alkane is nothing but from alkyl halide. From alkyl halide. Okay. Now, before going to start this, I just want to tell you the meaning of alkyl halide. Alkyl means any alkane has one less hydrogen becomes alkyl. So for example, if I have methane, okay, methane has 4 hydrogen. When I'll remove one hydrogen from methane, it becomes methyl. Okay, alkane, alkyl, alkane, alkyl. Okay, second member C2H6, which is our ethane. When I'll remove one hydrogen from this, it will left with C2H5 with one free valency, ethyl. Okay children, so alkyl, methyl, alkyl, ethyl, alkyl, propyl, butyl, and so on. Okay, halide is nothing but shows the presence of halogen. Okay, so when I'm writing F2, we'll consider it as a halogen. Which halogen is it? Fluorine. But when fluorine, this is fluorine, this is chlorine, this is bromine, this is iodine. So when these halogen make bond, becomes termed as halide. Okay. So how I can represent alkyl halide with general formula RX. Okay. R is alkyl, X stands for halide. Okay, children. Okay, let's start the reaction. How we can get alkane from alkyl halide. Okay. What is my aim? I want to prepare alkane from alkyl halide. It means I need any substance which can replace X and gives the H. Okay. What we can use? So here important reaction conditions. What reaction conditions you need to do this reaction to get an alkane? Okay. So number one condition, we need a catalyst. Okay. What is the use of a catalyst? Catalyst alters the rate of the reaction. Mostly catalyst speed up the reaction and gives a good quantity, good yield of the compound. Okay. What we can take? Number one catalyst we can use zinc in presence of hydrochloric acid. We can use zinc in presence of acetic acid. We can use LiAlH4, lithium aluminium hydride. I can use hydrogen iodide in presence of red phosphorus. Okay. Now, why do we use or why do we need these kind of catalyst? Why not only transition metals as we use in the first preparation method, which is hydrogenation? Reason. Children, listen what I said. I want anything, any substance which can replace my halide and provides proton. I need proton is nothing but I need hydrogen, right? So zinc will provide its surface. Zinc is also a transition metal, atomic number 30, 3D element. Hydrochloric acid, strong acid. CH3COOH, acetic acid, which is a weak acid. Lithium aluminium hydride is a reducing agent. HIN, red phosphorus, again an acid. So acid provides hydrogen ion. Okay. Acid provide hydrogen ion. So when my alkyl halide is going to react with any one of the catalyst, the halide will be replaced by the metal ion and acid will give H plus and make the alkane. I hope it is clear. Let's write the chemical reaction. So alkyl I am going to replace by my methyl CH3. Okay. Halogen I am taking as, or halide I am taking as a chlorine. So this chlorine, when it is in bonding form, it becomes chloride. So the name of this compound is methyl chloride. Okay. Reacts with hydrogen in presence of zinc and any source of acid. Okay. What I'm going to get? What I'm going to get here? CH4. Okay. And HCl. Children, is this clear to everyone? Okay. So this methyl chloride, this hydrogen, again, this hydrogen is what? This way. One hydrogen will make a bond with Cl and one hydrogen will attack to this methyl to form alkane. Is this clear? You can replace alkyl with ethyl also. So ethyl chloride becomes ethane. There will be no change in carbon atoms. Whatever, how many carbon atoms you are taking as your reactant, that many carbon will be there in your product. Okay, but yes, the yield of the product will be good because we are using catalyst. So you can see this, the preparation method from alkyl halide or the formation of alkene from alkyl halide is nothing but a reduction process. Okay, it is being reduced. All right, one more example, I'll write it here. Can I erase? Okay. So, if I say C2H5I, okay, C2H5 is what? Ethyl. I stands for iodide. Can I write ethyl iodine? No, it's wrong because iodine is in the bonding form. Iodine becomes iodide. It is in ionic form, I minus. Okay, when it reacts with hydrogen iodide, as I told you, when I am using hydrogen iodide, as we know that iodine reactivity is very less due to its very big size. Okay, in presence of red phosphorus, what I am going to get? Iodine plus alkane. Which alkane? Ethane. Okay, this hydrogen will come here. This I will make a bond and form the iodine. What is the use? Highlight. What is the use of red phosphorus? Red phosphorus prevents backward reaction. Otherwise, what will happen? Just imagine, okay? Imagine if we do not use red phosphorus, this iodine will break down into hydrogen iodide and we'll get our alkyl halide back. What is our aim? To prepare alkane from alkyl halide. So we have to stop the backward reaction. So to stop that, we have to use red phosphorus. Is this clear? Okay. Now, next preparation method, our next recipe to prepare alkane is very important, very important. Now, name reaction I am going to start, which is very important from exam point of view. You should know the reaction condition. Okay, which reaction is that? This reaction is called as Wurtz reaction. Which reaction is that? Wurtz reaction. Okay. Now, very important, this reaction we use to increase the carbon chain length. Okay, important. Please make a note. This reaction used to increase alkyl chain. It means if you are taking one carbon atom as a reactant, you will get 2. Okay, if you are taking 2, you will get 4. Okay, so you can see by using Wurtz reaction, we are getting even number of carbon atoms. And this reaction also you can say that this, by using this reaction, the number of carbon atoms in the product will be more. So we can say Wurtz reaction is used to ascent of carbon chain. Please make a note. This reaction means Wurtz reaction used to ascent of chain. Ascent of chain means to increase the length of carbon atom. Okay, I am going to write the general reaction with one example, and then children you can practice or you can try to write one more example by taking any other alkyl group. Okay, so Rx. Again, what is Rx? Rx stands for alkyl halide. Okay, in presence of 2 sodium atoms, I am going to take one more alkyl halide. Very important, in presence of dry ether. Don't forget, this is important. Presence of dry ether. What I'm going to get? This X will make bond with sodium and will come out as sodium halide, and I will left with R. Okay, so R plus 2NaX. Okay, now example, methyl chloride reacts with 2 sodium, then 1 more methyl chloride. In presence of dry ether, this will come out as 2NaCl, which is nothing but sodium chloride, and I am going to get this and this, which is CH3 ethane. What I used? Methyl. I got ethane. Is this clear? If I'll use ethyl chloride, I'll get butane. Children, is this clear? Clear? Star mark. In exam, how they can ask you? Okay, in exam, they will not give you that long equation. You should know if the reaction is undergoing or reaction is taking place in presence of sodium plus dry ether, it's nothing but the Wurtz equation. Okay, they might give you in the exam C2H5I, okay, arrow, sodium, dry ether, what will be the product? Okay, so it's understood when you have sodium and dry ether, it's understood that you have to take 2 molecules of ethyl iodide and you will get C2H5, which is nothing but C4H10 butane. Okay, so reaction condition is very, very, very important in name reactions. Okay, so Wurtz reaction, again, what happens in Wurtz reaction? Wurtz reaction is nothing but it used to ascend the chain. Which chain? Carbon chain. Reaction condition, sodium plus dry ether. Now, what is the mechanism? How this reaction takes place? So, mechanism is equally important for naming reaction. So, mechanism, this Wurtz reaction takes place by free radical mechanism. Okay, let's see what is free radical mechanism. Children, have you noted it down? Please complete it quickly. All right. Now, free radical mechanism. Okay, mechanism. Which mechanism? Free radical mechanism. Okay. All right. What is the reaction condition I told you for the Wurtz reaction? That we need 2 sodium atoms. Okay. I know that the atomic number of sodium is 11. Electronic configuration will be 2, 8 and 1. So children, if you have any doubt how to write the electronic configuration, how to make the formulae, please write in the comment section. I will send a video on that. Okay, so 2, 8, 1. So sodium, what is the nature of sodium? To lose or gain of electron. It's a metal, it always lose electron. How many sodium do we have? 2. Each sodium loses 1 electron. So 2 sodium will lose 2 electrons. So I'm going to write 2 electrons here. After losing of electron, sodium atom becomes sodium ion and 2 sodium ion. Okay. Now, apart from sodium, I used Rx, which is nothing but alkyl halide. How many alkyl halide did we use? 2. Okay. So, we know that halogen, its nature is like that. It pulls the shared pair of electron towards itself and acquires a partial negative charge, which is nothing but called as electronegativity. Okay, so I know that out of these two, halide is more electronegative. It pulls the shared pair of electron towards itself, acquired partial negative charge, and alkyl acquires partial positive charge. Okay, and it creates the polarity. Okay, so I'm going to get this 2x minus plus 2r plus. Is this clear? Now, this R is attracted by the electrons. R plus means electron deficient, and if it can see electron, it will happily or readily accept the electron. Okay. Now, I have 2R plus here. How many electrons does it has? 6 electrons. It will accept 2 electrons. So, 2R. Okay. Each R will be having 7 electrons. Each R has 6 electrons, will accept one more, becomes 7 electrons. Okay. Now, how it will be? Okay. This X takes the electrons and comes out as halide. Carbon will left with 3, which is a carbocation. When carbon has positively charged ion, known as carbocation. Okay. Now, when this carbocation takes electron, it converts to free radical. This is my carbon free radical. Is this clear? Right? So this is the mechanism of Wurtz reaction. So keep in mind when you are taking two halides same, like when you are taking both halides same, you are going to get even number of carbon atoms. When you are taking one even, one odd number of alkyl halide or carbon atoms, you are going to get odd number of alkene. Is this clear, children? Okay. Please note it down. Alright. So our next preparation method is from carboxylic acid. Okay. This is our next preparation method from which we can get alkene. क्या हुआ?
अरे कुछ नहीं बोलना
तो फिर तू ऐसे इशारा करती तो फिर कौन? Alright. So carboxylic acid, it means any compound when it has COOH as a functional group. When this COOH present as a functional group is known as carboxylic acid. Alright. Don't forget to give the number to this carbon atom. This carbon atom always present at the corner or as a terminal carbon atom. Right. So by using carboxylic acid, we can prepare alkanes by two ways. What is the first way through which we can prepare alkane? So number one, we can prepare by using Kolbe's electrolysis method. Okay. So electrolysis means what? Lysis means breaking down. Okay. What breaking down? By passing electricity. So when compound broken down into smaller substances, when compound broken down into its constituents, when substance broken down into its ion, by passing electricity known as electrolysis. Okay. So by using Kolbe electrolysis process, we can prepare alkene. Alright, is this clear? Okay, so what we have to do? We have to take sodium, right, star mark. So we have to take here sodium or potassium salt of carboxylic acid in aqueous medium. Okay, we have to use to gain alkane by Kolbe's electrolysis method. We have to use sodium or potassium salts of carboxylic acid. First of all, how we can prepare potassium and sodium salts of carboxylic acid? So we know that if I am writing RCOOH, okay, R can be hydrogen, R can be any alkyl group, okay, can be methyl, can be ethyl, can be propyl, and so on. When you replace this hydrogen, when you replace this hydrogen by sodium or potassium, I'm going to get RCOONA or RCOOK. This is called as sodium source of fatty acid, sodium source of carboxylic acid, potassium source of fatty acid, or potassium source of carboxylic acid. Okay, so you have to prepare first this salt by this reaction, and then this salt, potassium and sodium salt, you have to use for the chemical reaction. Let's see what's the chemical reaction. Okay, so this RCOONA, sodium salts of carboxylic acid, okay, undergoes hydrolysis, reaction with reaction with water. Okay, what will happen? What I'm going to get it? I'm going to get, so here for this you have to take two molecules. So here CO2 will come out. Can you see this COO bond? Right? So this CO2 will come out as one of the product. Okay. Then as I'm taking 2R, so I'm going to get higher alkane. Okay. I'm going to get higher alkane along with formation of sodium hydroxide. Okay. And liberation of hydrogen gas. Is this clear, children? Okay, so this I'll replace R with CH3. So CH3COOH, which is nothing but acetic acid. The name of this compound, common name is acetic acid, and IUPAC name is ethanoic acid. Okay, ethanoic acid. So this acetic acid, when reacts with water molecule, so you have to take 2 acetic acid. When it undergoes electrolysis process, so as electrolysis means you have to take an electrolytic tank in which you have to insert cathode and anode, and you have to connect this cathode and anode with the battery. When you pass electricity, okay, when you pass electricity, we know that anode is positively charged and cathode is negatively charged. So towards anode, negatively charged ions are going to attract and deposit, and towards cathode, which is negatively charged electrode, and towards that positively charged ions are going to attract. All right. So here by electrolysis process, 2 molecule of carbon dioxide I'm going to get as one of my product. Okay, this upward arrow shows the liberation of gas. Okay, then I have taken methyl, but I'm going to get CH3. Okay, I'm going to get CH3. So how many CH3? All right, then NaOH, and then hydrogen gas. Is this clear? Anyone, any doubt? All right, this is the product. So I used methane, I got ethane, higher the alkane. Okay, now just keep in mind, children, whenever, have you done Have you noted it down? I hope you all are maintaining one notebook. Okay. Now, write some few important points which is very important for electrolysis process. So, whenever you are doing electrolysis process, it's very general information about electrolysis. We have two electrodes. One is anode, which is positively charged electrode, and another one is cathode. Okay. So anode and cathode, two electrodes we use for electrolysis process. At anode, what happens at anode? Electron will be released. Okay. And at cathode, electron will be accepted. Okay. Loss of electron. Loss of electron. Electron being released means what? Loss of electron is known as oxidation. Okay. Gain of electron. Accepted means gain of electron is known as reduction. So I can say this is also one of the example of redox reaction. Alright children, redox reaction where the oxidation and reduction takes place simultaneously. RED stands for reduction, OX stands for oxidation. Okay, this chapter also you have one entire chapter, redox reaction. If you find any difficulty in that chapter, please write in the comment section. I will explain that chapter in very easier way with lots of tricks. Is this clear? Till here, have you noted it down? Quickly write it. Yep. Let's start. Next. Okay. Now, I'm going to write, I have given the general equation for coal-based electrolysis process. And I have taken one example of ethanoic acid. Can you write? Will you try to write the reaction with ethyl as R group? Okay. You have to replace R with ethyl group. Okay. And you have to write the acid. What it will be? So RCOOH. So I'm going to write C2H5COOH. Who can give the name? Who can give the name? This is my C2 plus 3 propanoic acid. Okay, propanoic acid. Now you have to replace one hydrogen. Why do we need to do that? Because we need sodium or potassium salt of acetic acid. Sodium or potassium salt of propanoic acid. So when I remove this hydrogen, I have to add either sodium or I have to add either potassium. So I will get C2H5COONA. What is the name of this? You have to write positive part first, which is our sodium. Okay. And 2 plus 1, 3, propanoate. Okay. Propanoate means which function group do we have here? We have ester. Right. Sodium propanoate, we got it. Now, how many we have to take? We have to take 2 moles of C2H5COONA reacts with 2 moles of water, undergoes electrolysis. Which electrolysis? Kolbe's electrolysis. Okay. And what I'm going to get it? I'm going to get C2. So I'm going to get C4. Double number. C4H10, which is nothing but butane. Then 2 molecules of carbon dioxide. Okay. Then 2 molecules of sodium hydroxide and liberation of hydrogen gas. I hope it is clear to everyone, children. Is this clear? Right? This reaction takes place by free radical mechanism. Shall we just see what mechanism and how free radicals forms? Quickly finish it. Then we're left with only one reaction process, preparation process, which is nothing but soda lime. Okay, this is first process. There is Kolbe's electrolysis process under the carboxylic acid. Okay, so you can see here liberation of carbon dioxide is taking place in each and every chemical reaction. So I can also call this Kolbe's electrolysis process as, it is an example of decarboxylation reaction. Okay, D means removal. Okay, D means removal of carbon dioxide. Is this clear? All right, then writing. Shall we do the mechanism of butane? Let's go. Okay, put the heading mechanism. All right, mechanism. What's mechanism? As I told you, which mechanism takes place? Free radical mechanism. Okay, what did we use here? We use C2H5COONA, sodium propanoate, 2 molecules. When you, okay, so this C2H5COONA we use on passing electricity, and this bond is going to break. Okay, sodium will come out in the form of sodium plus, and C2H5COO minus will come out in the form of acetate ion. Okay, so I'm going to get C2H5COO minus plus, I'm going to get Na plus. How many C2H5COO? 2 molecules. So write 2 molecules as it is, 2 sodium, 2 Na plus. Okay, along with this we used 2 molecules of water on passing electricity. We know that water is made up of H plus and OH minus ion. So we are going to get 2 H plus ion and 2 OH minus ion. Okay, now what is happening at anode? We know our anode is positively charged. Okay, loss of electrons at anode. What will happen? So you can remember like this, oil. Okay, what is oil? Oxidation is loss of electron. Okay, oil, oxidation is loss of electron, which happens at anode. So oxidation takes place at anode. Okay, now this C2H5COO minus, what this negative sign shows? This negative sign shows the presence of electron, extra electron. Okay, so this will convert into free radical. Okay, and this electron will come out like this. Why 2 electrons? Because I am using 2 molecules of C2H5COO minus. Okay, when you write this dot, it represents the free radical. Okay, now this further, it will dissociate, right? This will dissociate into ethyl free radical. It will dissociate to ethyl free radical. Better to write free radical on carbon, because carbon only makes a carbocation and anion. Alright. along with, so this COO comes out in the form of carbon dioxide gas. Okay, so now we have two ethyl free radical. Okay, so what is the possibility? What you are going to get? So this one, two ethyl free radical going to make a bond like C2H5 hyphen C2H5, which is nothing but C4H10 is our butane. Children, is this clear to everyone? At anode, what is happening? At anode, oxidation is happening. So you can remember at anode is oil. Oil means oxidation is loss of electron. Please quickly write it. Finish it. So that we can discuss for cathode what is happening at cathode. What will be the product? So question can come, what is the product? Product at, okay, make a star or write, product at anode. So at anode our product is butane. Alright, now let's see funny. Okay, so this happened at anode. Okay, now what happens at cathode? Okay, now one of the product was hydrogen. If you know the reaction which we have done. So what happens at cathode? Cathode is RIG, rig. What is rig? Reduction is gain. Okay, rig is reduction is gain of electron. So H plus ion. Okay, H plus ion accepts electrons. How many hydrogen? We have two hydrogen. So one hydrogen accepts one, so two hydrogen will accept two electrons, and we are going to get hydrogen as a product. Okay, so again star mark, product at cathode is hydrogen. Is this clear? Any doubt? Have you noted it down? Quickly note it or take the screenshot. Alright. Okay. One important thing. This Kolbe's electrolysis process we can use. Okay. Important. This method can be used to prepare symmetrical alkene. Symmetrical alkanes. This is the alkane preparation method. So symmetrical alkanes. Okay. Symmetrical alkanes means even number of carbon atoms. Okay. One more important for Kolbe's electrolysis method. You cannot prepare methane, cannot be prepared by this method. Reason? We need, you know that we use 2RCOONA, means I need at least 2 carbon atoms. Sorry, we need at least 2 carbon atoms to make the free radical. Okay, so methane cannot be prepared by this Kolbe's electrolysis process. Is this clear, everyone? Okay, so this is about the Kolbe's electrolysis process, which comes under the carboxylation or from carboxylic acid. Now our this is our second preparation method from carboxylic acid and last preparation method of alkane is from soda lime. Okay, from soda lime. Okay, now here this process is used. This process is used for descent of carbon atom. What do you mean by descent? Descent means degradation. To reduce. Degradation. To reduce the number of carbon atoms. Okay. Now first of all, when I am saying soda lime, what is soda lime? Soda plus lime is soda lime. Okay. Now soda is nothing but NaOH, sodium hydroxide, and lime is nothing but calcium oxide. Okay. So here we have to take sodium, salts of carboxylic acid. Okay, what is the chemical reaction? So CH3COONA, sodium acetate, reacts with NaOH, soda lime. Okay, so you have to heat. Okay, what is the reaction condition? Heating. How much heating? You have to heat at high temperature. How much high temperature? 350 degree Celsius. So sorry, this should happen, otherwise my video cannot be completed. Okay, so CH3COONA plus NaOH. What I am going to get? What is going to remove? So we know CH3 is going to make a bond with this hydrogen. It means from here to here is unwanted. We do not want in our product. Okay. So what I am going to get? I am going to get CH4 as a product and Na2, CO1, 2, 3, CO3, sodium carbonate. Methane is our product. Now check here. We used 2 carbon atoms and I got 1 carbon atom. Degradation, reduction of number of carbon atom. Is this clear? Okay. Quickly write the IUPAC name. I am giving you a minute to think and write the IUPAC name. Common name I am giving you. It's a sodium acetate. Okay. The common name is sodium acetate. Who can write the IUPAC name? Quickly write in the comment section. Quickly. Okay. Shall I write it? So, the IUPAC name is sodium ethanoate. Okay. Now, here if you have observed, we have used sodium hydroxide and calcium oxide. So, sodium hydroxide, if you have seen, it has a white color palettes. Okay, if you have seen this in your chemistry lab, sodium hydroxides are nothing but the white color palettes. If you keep sodium hydroxide out for some time, it absorbs moisture. Okay, so any substance which absorbs moisture, we can say sodium hydroxide is absorbs moisture readily. So it is hygroscopic in a nature. Okay, it is hygroscopic in nature. Okay. Now, due to this, if you keep NaOH outside longer time, you may not get the proper yield of the compound. So, to stop this or to control this behavior or this nature of NaOH, we use calcium oxide. Okay. So, calcium oxide is not hygroscopic in nature. It stabilizes. It is not hygroscopic. Okay. It stabilizes NaOH and the chemical reaction. It stops, it prevents the absorption of moisture. Okay. So NaOH can absorb moisture, but it prevents the NaOH and water reaction. Alright. Is this clear, children? So here we have done with the preparation of alkanes. I'll give you one reaction. Okay. Have you done? Have you noted it down? Take a screenshot if you want to take. Yes. Alright. Now, last question. What type of question can be asked in the exam? Okay. Now see. If you have C2H5 COOH, okay, when it undergoes soda lime, okay, on heating, what will be the product? Okay, you have to write the answer in the comment section. Next video, we are going to talk about chemical properties of alkanes. We have done with the preparation method of alkanes. Next video, we are going to talk about the chemical properties of alkanes along with the answer of this question. Till then, see you. Bye-bye. Please like, subscribe and share my video. See you. Bye.